All right. Try to get the angle so that we see that we have a screen here, although we got students in the corner here I don't want to block out. Okay. Oh, that's not right. What am I doing? That's the actual printout. Boink, boink. There we go. Okay, I don't know how that moved there. All right. So we should already have these answers. If you don't, you're severely and totally anyone behind. Yes, I have said that before. Okay, because this is just based off. Oh, this was a trick though. Bang. Oh, you didn't look at the highest degree, so it doesn't always have to be in order. So what's the asymptote? Y equals, right? -5/2. That's when the degrees are equal. Okay, at this point, it should just be memorized. Fine. Equal degrees, y equals coefficients. But here's the reason one last time, and I'm not going to cover it again. When I plug in 100, boy, oh boy, let's just plug in 10. When I plug in 10 for x, that's 1 with 6 zeros now. That's what 10 to the 6th is, right? Everyone knows how to do that? Okay? Times -5. So that's -5 with 6 zeros. What's 6 zeros? Is that -5 million, right? Over 2 with 6 zeros. What does that reduce to? -5/2. So that's why this is what end behavior asymptotes are. When I plug in big numbers, what's the output becoming? Input? Say it. Output. It's all input, output, everything that we can cover. Crinkle, crinkle. That's the time. All right, next one. What's this one then? Y equals what? 1/3 reduced. Okay, so fine. Okay, we're done with the reasoning. Sorry, that's a 3. That's terrible. We're done with the reasoning. Rule is degrees are equal, y equals the coefficient. Then the rule is, oh, wait a minute. I gotta FOIL this in my head and then multiply it by another x plus 4. Ultimately, you should know that this is an x to the third up on the top. Don't FOIL, but pretend if you did. You got to at least understand that. I don't know, man. And then x to the 4th times another x, that would be 1x to the 5th. Not that I need the 1. So I got to have some sort of knowledge of foiling there to understand that this is what we have. So what's the asymptote? Y equals what? And then that's the reason. Okay, one last time. Input, say it. When I put in 10, I get 1 with 3 zeros in the top. That's 1,000. Over 1 with 5 zeros on the bottom, which is 100,000. 1,000 over 100,000 is 1 over 100. I hope I'm not embarrassing myself. But 1 over 100 is 0.001. That's almost what? 0. When I plug in 1,000, it gets more ridiculous. And then it becomes 0.000. This is the point. When I throw in large numbers, I get 0 almost as outputs. That's why this is the end behavior asymptote. Then answers may vary on this. I'm just going to make my life easy. So g of x would have to be something like this. Hopefully you read the question. So I told you to do it. When you don't do these things, you're getting close to the wall licker territory. All right, someone that just doesn't do what they're supposed to be doing when the teacher asks them. Can't pay attention. All right, 4x minus 1 over 5x plus 3. Why did I add these? Just so I don't just put 4x over 5x because that would cancel, right? The x's would cancel. I need something to make it not canceling. Or it could be 4x squared over 5x squared, or it could be 4x cubed over 5x cubed. The idea is the coefficients should be equal. And here's the link here. Limits are related to what the asymptote would have to be. And that's what we had on our quizzes. I did that a couple times and then turned it into a limit question, but then the limits are related to the asymptotes. Go ahead.
So like instead of -1 and 3, you can put like
anything. It could be anything. 4x cubed plus 74 over 5x cubed minus 1 million. It wouldn't even matter that minus 1 million would eventually become insignificant as you plug in big numbers. Infinity is a crazy idea. Okay, now we're into this. What did we say about this yesterday and the day before? Is there a horizontal asymptote? Yes or no? No, so put that right below here. There's no, when the degree is bigger, and that's what we're doing today. There's no horizontal asymptote. And that's all we said. But then I said, hey, we're going to, in Monday's notes, I said we are going to find what the slant asymptote is. And then I'm actually going to do it right here because you are physically going to have to find. We literally just went over the quiz in our meeting today that we weren't supposed to have. It was supposed to be a mental wellness day. I just want to talk to somebody because I'm going crazy, right? And then we still ended up having a meeting. The whole idea of a mental wellness day is that we get to just have time by ourselves. That was taken away from me this morning. Thank you. I was searching for that. Okay, now, here's where the input-output happens. And this is why this is bigger than that. So when I plug in 100, I did plug in 100. And look at what the number is. I'm going to come close to it. Watch. This is actually the output right here, 203.09. But close enough. When I plug in 100, I should have plugged in 10. But anyway, 100 squared is 1,000. So that's essentially 2,000 over 100. All right? Wait, 100 squared is 10,000. I was never good at math. So 20,000 over 100, which is around 200. But it's actually 203.9 because of the other parts of the equation. Input, because I see people looking at me with glass eyes like, where did he get that from? This is what's happening. All right, so when I plug in these numbers, look at what the y's are doing. Where are they going to? In infinity. All right, and then where are these going? To what? Negative infinity. So that's you know what? This is an input. Say it one more time. Let's do this for the first time in forever. So when I plug in infinity, that's what I'm getting for y. I should have done that in the charts and Monday's notes. Well, let's go to it. Okay, let's go to that chart. We didn't do that. Okay, let's go to that chart. Yeah, you know what happens when I plug in infinity on this one? You don't have to get the notes. When I plug in infinity for x, I'm getting 0. Okay, that's what the difference was in that chart, right? That's the one where we had a horizontal asymptote of y equals 0. But I can't do either. I can't get the biggest number ever. That's the idea of infinity. It's an abstract concept. Okay, so anyway, that's what's happening there. And then maybe just to finish that thought, when I plug in negative infinity, I'm going to get negative infinity if I could. And that's the limits. That's what the limit statements say. Okay, so down here, we can fill those out. As I plug in negative infinity, I get negative infinity. As I plug in infinity, I get positive infinity. Oh, okay. You know what? You had these in your homework. You had these in the homework. I'm in the way of a student. It's going to hurt her neck here. All right. We had these. Okay, and again, I'm going to come up to the screen. Inputs. Okay, so 6 comma, 8 comma, 10 comma. Where's my finger go for y as I plug in big X's? Where's it going? Infinity. And then input, output, input, output, input, out. Where's this y finger going as I plug in big numbers? Negative infinity. So that's why that, you had pictures like this on your homework Monday, and you should have been able to figure that out from a picture. Right? That's different than horizontal asymptote behavior. You know what? We're physically going to find this because we actually have to do this. We actually have to find what the slant asymptote is on your test a week from tomorrow. It's actually a quiz, a little less points. Hey, what am I doing there when I show that symbol? What's that called? Synthetic division. You know what I'm going to physically do? I'm going to physically divide these two. So I'm physically going to divide by x minus 2, which means 2 goes in there. And then 2, negative 1, 3. 2, negative 1, 3. This is physically finding the slant asymptote. I'm going to have you put that in the graph. Nice drinking job there. I don't have to say what, everyone. Crinkle, crinkle. Then 2 times 3 is 6. Now, I feel like that's different than... No, I guess that's fine. Okay, then remember, when I synthetically divide, what happens? This is x squared. Now it's x, depressed polynomial, plus 3 plus 9 over x minus 2. Okay, now, this is the slant asymptote. I'm going to prove that the graph behaves to this line. Do this, though. and this is going to be shown up later. You really don't need that part. If you wrote that on a written part of the test, I think you should be fine, but it's irrelevant because this is the idea of plugging in large numbers. When I plug in large numbers, this part becomes 0. 9 over large is 0, so it becomes irrelevant and insignificant. So let's just analyze this. 2x plus 3, y equals. Let's go to this picture. 2x plus 3. And if you don't know how to graph a line, there's the door. Coming in with these things, not knowing how to do this. Plus, we already graph lines. That was the first thing that you got in the beginning of the year. So y-intercept is 3, and then you rise to, this is 3, 4, 5, and then run 1. That scale is 1. And then I'm going to zoom back and say, okay, 2 points make a line. So I'm going to try to draw this dotted line as, oh, yeah, look at that. Look at that graph there, and look at that graph here. It seems to be behaving towards that line perfectly. You see that? That's why this is a slant asymptote. It's directing the graph at the ends. So we are, on Thursday, going to put this all together and graph these and figure out how we get these parts of the picture. It's going to be actually quite easy, I hope. If you get everything down about asymptotes. And then tomorrow we're going to do holes. Anyone ever see the movie Holes? When they're digging, and then the mean adults, and anyway, has nothing to do with tomorrow, but okay. Now you will not have to do this physically and find this slant asymptote. In fact, it's not a slant asymptote. This is shown on the next page, but I'm going to do it right now because I want to explain something about this graph. First of all, let's explain this because this is knowledge we should already know. There's a vertical asymptote at x equals 1/2. How did he get that? He set the denominator equal to 0 because it can't equal 0. And that's why there's going to be an interruption in the graph at that spot. Look at that. Right there, that vertical asymptote is at 1/2. Do you see it? Do you see it? Do you see it? You can't see it if you're licking the walls there. All right, so make sure you look over here. Got it? All right. But now let's go to this. And obviously we can see that if I plug in infinity, I'm getting infinity. These y's are going crazy. That's the answer to the limit statements. But I want to take it a step further. The asymptote is not slant. What's x cubed divided by x? X to the what power? You guys don't know this? It's x to the second. All right, and then what's 4 divided by 2? So this is a parabolic asymptote. It's degree 2 parabolic asymptote. I just put S either. Okay, parabolic asymptotes. And then look, if I ignored this stuff in the middle, doesn't this look like a parabola? Here and here, right? The end behaviors. And that's what's going on. So that's there. Can we all say this word together? Oblique. 3, 2, 1, go. Oblique. They're actually supposed to be called oblique asymptotes. Slant asymptotes are linear. All asymptotes that are beyond that are called oblique. All right, because that's certainly not a slanted line. That's a parabolic asymptote. Now again, you kind of just have to have that idea. This one, we're not going to make you find equations of parabolic ones, but we should at least know the leading charge here. There's some other stuff to that, but we at least know it's a parabolic asymptote facing up and up. So, we really should get this. These are both infinity because that's what those ends are doing. Input, say it one more time. We wouldn't even need this. If I just looked at this picture, as I plug in big negatives, the y's go off to here. So I should know that that's infinity. And then as I plug in big x's, the y's go off to there. That's another positive infinity. So the picture alone should have been enough. Right, Dom? Now, remember the notes from Monday? No. Well, the notes from Monday had 3 cases. This is case number 3 from Monday's notes, where we said, hey, when the numerator's degree is bigger than the denominator, there's no horizontal asymptote. But I did say on Monday there's a slant asymptote, and I did say on Wednesday we'll cover what that is and how that works. And here we are now, Wednesday. Okay, so notice right here, this is called, oh, there's the word. Can everyone say that word? 3, 2, 1, go. Oblique. That covers all asymptotes, slant and then greater than linear. Okay, and then this is what they tell you to do. F of x has the end behavior of, it is that coefficient in front of those leading degrees, but then x to the numerator's degree minus the denominator's degree. So we're going to just do that real quick. I will tell you on letter A, we reduced what people had to do last year compared to what you have to do this year. You would have to actually long divide these two. But look, the degrees numerator is 1 bigger than the denominator. So if I were to long divide this, then the first term would be y equals 3x to the fourth over, what am I doing? 3x to the fourth over x cubed. That would be the first term, which is y equals 3x, and then there might be something else after that. We just won't make you long divide on this one. We'll only have finding slant asymptotes if it's a nice little linear denominator that we can synthetically divide. We're really simplifying things for you here. So y equals 3x, we have to understand that's how this graph will behave. So here's where 3x is. So it's got like a slant like this. And just as you don't have to do this later, but I just want you to understand. And then the graph might have some vertical asymptotes somewhere, but the graph would probably look like this. It probably look like this, and then look like this. Meaning the ends are just going to be dictated by that line that has a slope of 3x. Got it? The reason I need to know this is input, say it. As I plug in big numbers for x, where does y go? Where does y go? I'm going to hurt myself. Up to what? What number? Infinity. All right, and then as I plug in big negatives, where does y go? Don't make me hurt my back. Negative infinity. Okay, so my left asymptote, my left end behavior, limit of f of x as x approaches negative infinity is negative infinity. That's this end. That's this end. So it comes from the knowledge that I have a slant asymptote that at least has a slope of 3. Y equals 3x. All right? All right, and then maybe doing a little bit more clear here than I did first hour with this highlighting. Limit of f of x. And again, you don't worry about the graphing yet. We're going to put this all together. Wait, I said Thursday. Friday. I have my days off with first hour. Tomorrow's Thursday. We're doing holes Thursday. Then Friday, we're just going to put it all together. This is how you graph a thing. All right? Asymptotes, x-intercepts, y-intercepts, and then how do you get the picture? And then that should be good. Friday should be a good day. All right? But anyway, that's the blue part. We'll cover this here because of this line being, hey, what does blue and yellow make, by the way? I'm sorry. Yeah, what does blue and yellow make? Look, now we're teaching colors. I do more than just math in here. Okay. Minimally, you will have y equals 2 over 6. And then what's x to the fourth over x to the fifth? What's x to the fifth over x cubed? X what? Squared. This means we'll have a parabolic end. Parabola. That means if I looked at this picture, that's kind of weird on the bottom, so I can't really analyze that. I don't want you to overdo it. But you have some stuff in the middle, but at the end, the graph will look and end like this. Okay, just like this picture here. Even though, you see, we got some goofy stuff in the middle. We got a vertical asymptote and a whole bunch of different things could happen in the middle, but at the end, it ends parabolically. Okay, so that's a minimum we have to understand there, so that we can fill out these limits. Hey, let's get lazy. Let's say limit of f of x as x approaches negative infinity. What's the answer? Where's it approaching? The wrong. Where does that approach? Still would be the right answer. Same answer though. Infinity. And then this one would be infinity and beyond. Anyone know what that is? Okay, and then don't get tricked. Don't get tricked. Oh no. What kind of asymptote is this? It starts with the C. Cubic. Nice. This would at least be y equals negative 4/5 x to the 4th over x, which is x cubed. This is the end behavior oblique asymptote. You don't have to do anything more than that. But what you do have to understand is how does a negative, here we go, how does a negative x cubed end? I'll just give you two choices. Is it this one or is it this one? Which one is it? Second one. So the asymptote would be something like this. This wouldn't happen in the middle of the function. As a matter of fact, this one I could find the vertical asymptote. It's 7/5. X equals 7/5. So something weird would happen in the middle, but not at the ends. This is how the ends would be. So that would be negative infinity for this one and infinity for that one. Wrong! I got that totally switched around. What a goofball. How embarrassing. How embarrassing on the video. My bad, dogs. Because this one goes with this one. All right, so that's why I screwed that up. Right? All right, and then I need nothing for this. Huh? I have 13 minutes. Someone's staring at the clock. Clock watching, wall licking, everything going on in here. All right. Hey, where's that arrow going to very slowly? Infinity. So let's write the limit one more time. The limit of f, let's not be lazy, but then be lazy in the next two. X approaches negative. These are great for multiple choice questions. Remember on my quizzes, they listed it as X goes to this, what does Y do? That they do that on the AP exam as well. So it's not always limit notation. But if they ask for limit notation, you better darn well do it, or else they'll mark you with the red pen of justice. All right, next one. As X goes to negative infinity, where does it look like Y is going? And by the way, I wanted to do this. Look, here's that nice little dotted line. That's a linear slant asymptote. Maybe sneak those in there. This one has a slant asymptote. That's linear. Because it flattens out at the end. So that's how it's different than a cubic. Wanted to show a cubic one, but I didn't do that. Anyway, so where does this going? Where's this going? Infinity. So this answer will be lazy is infinity. And then where's that going? Negative infinity. So that answer is negative infinity. Limit of f of x as x approaches infinity. Got it? And then what kind of asymptote is this? It's parabolic. We got some sort of parabola that's controlling the end of this. You don't need to know that. You just need to look at this. Where's that y going? Negative infinity. So attach this arrow to this and call this negative infinity. And then where's this arrow going? That's also negative. You guys this should never be missed. We have a whole section of just doing limits and some other stuff of the picture. It makes me sad, everyone that misses the whole section. I just don't know what we can do for them. Can only do so much. Can lead a horse to water. What can't you do? Force their face in the water and make them drink it. Right? You can't do that anymore. In the 90s, maybe. All right. Anyway. Okay. Now I did do finding the equation of a slant asymptote, and we'll probably do it one more time. I think these notes are a little short on this. And then let's look at these. Go ahead and answer these questions. And then panic in the streets now. I don't have the sheets. What do I do? All right. I didn't feel like printing one more piece of paper for 70 people just for this much content. So you can put this wherever you want. Okay, so I'll give you a second here. How much time have we got, clock watcher? I'll look. Now they're afraid to look. 10 minutes? Nice. Now you could just answer it verbally. You don't have to write it down if you don't want to. Okay, so identify which of the following has a slant asymptote. You know what? Forget that. We're going to find all the asymptotes. First of all, does this have a slant asymptote? Yes or no? Let's zoom in on this one at a time. Slant or no? Yes? Let's find it. What am I going to synthetically divide by? This is what you'll have to do. This is what you can do. No? What number? 3. And then 2, -1, 3. So you don't have this. She's still looking. Where's this at? Where's that? Okay, got it. I thought you were still searching for the example. Okay, I know. 3 times 2 is 6. I don't care. Couldn't care less. This is teaching in America. These are the things that happen in real life. Okay, x squared. This is x. And then this is 5. And then this is, what do I do about 18 over x minus 3, first of all? You can get rid of it. Did you hear him? Good. You can. If you wrote it, I would not mark you wrong. On a multiple choice, that part won't be listed. Just telling you because it's irrelevant. So this is physically what you will have to do. We literally have a multiple choice question. And then I have another one I think on the written that you might have to find a slant asymptote. Okay, no way. What's the asymptote of this one just looking at it? Did you hear him? Because it should be that fast. Everyone, it's y equals 0. Okay, again, this is just rules now. Dom, right? I'm worried about you. Every time I look at you, you're looking the other way. Okay. And then next. I didn't say his last name. We're all okay. I barely know anyone. So, Dom, you should be worried. I know your name, by the way. All right, anyway. What kind of asymptote is this? Nope. Parabolic. So at least we should know that it's around 6x squared plus ... That's how the ends would go. Because I don't want you to confuse this with other stuff. And this I don't think we're asking you that on the test. That we're only concerning with slants on the test. But it is nice to know. It's a nice to know. We used to do that. What do we need to know and what's nice to know? Okay, then look at this last one. I like this. Just read it. Don't write it down. Which of the following has a slant asymptote parallel to the line y equals 1/2 x? So a slant asymptote parallel to y equals 1/2 x. Very well worded. Let's look at the first one. Does that have a slant asymptote? Yes or no? No. What is this asymptote of this one? Y equals what? 1/2. Which is horizontal, not slant. These are equal, so that'd be a no. What about the second one? Hold on for a second. Now answer. What is this going to be? Y equals what? 0. The numerator's degree is smaller. And if you're like, oh my God, you can't memorize stuff. All right? That's your problem. You got to memorize. Okay, when the degree of the thing is smaller on the top than the bottom, then it automatically goes to 0. One more time, here's why. When I plug in 100, this is 100 squared over 2 times 100 cubed. This dominates. So since that dominates, it's small over large, which is 0. I don't know how many times I can tell you the why. All right, next. Does this one have what we're looking for? Does this have a slant asymptote, first of all? This is the whole idea today. You know, after talking and yip-yapping for this long, everyone should say, yes, this is what we're doing, Mr. Samuelis, today, and I listened and I understand. So this is one of them. And then what about this last one? What kind of asymptote is this? Parabolic should be that fast by the person in the back. So does that satisfy the scenario? Yes or no? No. So it would only been number 3. Got it? Okay, so this is a really good question that actually throws everything together from Monday and today. Tuesday we just did quizzes and Mr. Samuelis yelled at the students a lot for missing questions. Remember that?